Hi everybody, welcome to this edition of MOCPA Bar Talk. I'm Andrew Groh, and today we're here with Dr. John Seiffertt, Assistant Professor at Providence College in Rhode Island. Dr. Seiffertt, welcome to the show.
Thanks, Andrew.
If we can move to something a little bit maybe similar, but if I'm a CPA or CPA firm, and I'm hearing this conversation, and I'm thinking, how do I know if I should be thinking about finding a professional to come in and help provide some AI technology resources or solutions? How do I, if I'm a CPA, maybe a partner or an owner, where do those conversations start?
First of all, a good idea would be to get a sense of what the capabilities of the technology are. So if you have a lot of data, and if you have your accountants working on things like taking a bunch of receipts and organizing them into particular categories, then that is something that AI could definitely be deployed well to help you do. Because what you really want the AI to do is free the humans up to do things that only the humans can do. And there are limits to algorithms. We'll talk about that in the computer science curriculum as well. And that's where the oversell of what algorithms can accomplish can be dangerous, and then it can make the legit AI applications seem less interesting.
So put yourself, you're the owner of a mid-size, managing partner of a mid-size CPA firm or business, and you're hearing this podcast, you're hearing a lot of tech talk, and you're thinking, you know what, we know that we can streamline some processes here. Should I think about maybe looking at where RPA, robotic process automation solutions start first, and then take a look how big could this get? How big of a project should it be for AI? Or do we look at them, kind of in the same set of considerations? Where would you start?
I would say look at it from a perspective of what tools do I need to streamline my processes. If it's RPA, then use RPA. If you need something more than that, then use AI. If you're combining a bunch of files into one file and you don't need to categorize in a particular way, then RPA can do that. You can also have AI added to RPA. Like AI isn't a technology unto itself, right? It's like the engine of a car, and you have different types of cars that you can drive through. So AI can power RPA. AI can power data analytics and predictive analytics. So it's do you need that interpolation power? Do you want the ability to adapt as new data comes in and really think about those? So you have to decide for your workflow what kinds of challenges you're facing the most, what kinds of things do your human workers hate doing the most, like which of the ones just drive them mad, and those are the things to start focusing on. Because the great promise of artificial intelligence is that it can lead to human flourishing. It can lead to humans doing more human tasks. You want to be spending time talking to your clients about their goals and dreams. You want to spend time figuring out your client's situation with respect to tax authorities. Looking at their internal processes. And none of those things can be algorithmicized. None of those things can be expressed in the formal language of computer science. None of those things are things that can be taken over by AI now or in the future. So focus on what AI can do and use it to leverage the human capital that you have and put it on more human tasks.
Yeah, and that falls right in line with what our profession is really looking at the future of CPAs, and we talk a lot about the professional value chain, and moving CPAs up that value chain, and technology like AI and blockchain and RPA. Those are the tools that are right now being used to start moving those professionals up that value chain ladder. Are there other things that you're seeing maybe in maybe the business and industry space, maybe pulling away from CPA firms, but put your CFO hat on for a second. Maybe you're in manufacturing.
Right.
What would I be thinking about maybe a little bit different in this space?
Well, industrial automation is one of the great places where AI is doing amazing things right now. For example, you could have a robot. If you've got a huge manufacturing plant, you could have a small robot who would go around the shop and detect spills and clean it up. And you could have an army of humans having to do that, but having a robot do that could save a lot of time. And here's where you have to talk about mitigating downside risk. So is there a problem if the robot misses a spill? Not really. Like, who cares? Then your smaller human workforce will go find those. Or if the robot is going to make the other kind of error and try to clean up an area that isn't messy,
Right.
those are the two kinds of errors that the AI could make. That's not a big deal either. So in that case, you look at it and you say, well, how much will the robot cost versus how much are all these humans going to cost? And what is the downside risk of this robot? And it's trivial. So then you go into it, and we have robots in physical manufacturing.
But the risk portion of it, maybe, is that really what you're saying is a key set of considerations here? What if you go into that kind of decision, kind of tree? I know you don't like that kind of model, but you say, maybe I think that these robots can help clean things up, but gosh, the risk may not be worth it. Where do you start drawing those lines?
Well, that's where the risk assessment is really important. Maybe you're at some sort of a chemical factory where the types of spills are this terrible acid that will kill people if they get on it. In that case, the risk of a robot missing it is catastrophic.
Bad, yeah.
So in that case, maybe you would say, no, I cannot risk a single error, in which case an AI solution is probably not where you want to be. You want your armies of humans going around because they can be more reliable.
What if I'm working with a vendor who's saying, with that scenario and saying, Dr. Seiffertt, we got you covered?
Right. So there's AI vendors will say, well, humans make mistakes also. So there is some truth to that. You want to make sure that your AI solution is making fewer mistakes, right? If it has to make mistakes, maybe you have a way to tell if you have a situation where humans are guaranteed to err, then an AI solution that also errs can still be valid. It can still be valid, yeah. So machine vision is a place in AI that has achieved a lot of great success recently. So in some assembly plants, there are humans on the line whose job it is to look at the things being produced and grab them if they're deformed. Like if the manufacturing process messed up, you go grab those. And we can now have computer vision robots basically analyzing the items on the assembly line and picking out ones that should be removed. And in that case, again, you have the situation of what's the downside risk? Well, you have some good items will be removed and some bad items won't be removed. Both of those things will happen, and you have to make a judgment. Well, what is human error? What is the robot error? What is the price of
both, right?
Of both types of errors? And it's a process, it's a management process. But I would recommend to everyone considering these solutions to actually sit down and worksheet this all out, game it all out, and say, well, what are the things where humans possibly messing up, and where will the AI be able to help?
And what professionals are auditing those ideas? Where are those kind of risk management decisions made in risk management frameworks, or is it something different?
In the industrial plants, automation has a long and storied history. So electrical engineers, people who get engineering management degrees, they're kind of brought up in this world of technology, and let's figure out how to appropriately deploy the technology to help our plants generate our product. And in the business world, that has been happening a lot less. Mm-hmm. So I think more, you're talking about cross-disciplinary communication from the plant managers who have engineering backgrounds with the people that are getting operations degrees from the business school. Sharing those sorts of techniques and ideas would be a fantastic way forward to help figure out how to use AI.
Where are our financial engineers? Maybe that's what CPAs of the future actually look like, right? I don't know. That's maybe a half joke, but applying those same principles and the rigor to financial systems, audit systems, those types of things, potential for this profession. And I did want to ask. I mean, there's some pretty cool examples. In your history, your perspective, what are some, maybe one or two of the most interesting application and use of AI that you've seen it or come into contact with?
Well, one of the first applications that really made AI stand out was in playing games. There was a backgammon playing program in the 90s that was the first AI program to really beat the best humans in the world in a game. And what was amazing about it is not only did they beat them, they showed them new strategies. The AI was able to learn new strategies and produce games that the humans were very impressed with. Similar game playing technology today is also showing the light to some interesting strategies. Some of the games played by Google's AlphaGo program in the chess domain are rated by humans as beautiful, as interesting, as not just necessarily the result of a computer. Outside of the game playing area, which is often used as a test bed for algorithms, it's not that we think that learning how to play a game really well is of utmost importance. It's just a good way to test the algorithms. An area called natural language processing, where computers are trying to be able to have conversations with people. How can a computer understand the actual human written language or spoken language? That's a very, very difficult problem. And we're running into some situations now that can make you kind of very impressed with how well the computers are going. We can have several levels of exchange with, say, a chatbot, and you can't really tell if it's a human or not. Those are very, very interesting applications of AI that have exciting applications both philosophically and on the engineering side.
You talked a little bit about professional skepticism and risk management. Can you give us an example of where maybe AI doesn't live up to its performance expectations?
Yes, Andrew. There's a slide I've brought along with this that was a demonstration by Google engineers of how there can be potential flaws in these categorization algorithms that we talked about that are really hard to tell at first glance. So one of the things that AI is really good for is categorizing large amounts of data. Right? So you're going to have your different types of text information, and you want it in different areas. So we often use this in image recognition. So on the slide, there is a picture of a banana being correctly identified by an AI algorithm. So you can show it a bunch of pictures, and it'll say, oh yes, that is a banana, that is a dog, that is a house, these kinds of things. These are the sorts of test beds that we use. And so it looks really great, right? The advertisement would be great, right? The vendor would come to you and say, look, this always classifies this thing as a banana. One of the possible downsides, though, is that if you are just a little bit off, maybe it doesn't classify it as a banana anymore. And so
For instance, like what?
So in the graphic, what the Google engineers did was they introduced noise. We call this noise, sort of a disruption to the picture. They changed the picture very slightly. They introduced this weird psychedelic looking button, and they laid it next to the banana. And to a human would look at that and say, yeah, that's still a banana. There's a weird button there, but that's still a banana. But what the engineers did was they looked at the internals of the program generated by the algorithm. They looked at the actual program that was doing the classification, and they figured out that those particular inputs would cause it to misclassify the banana. And so it shows that the algorithm can call it now a toaster instead, even though it looks nothing like a toaster. That one little disruption can completely change what the classification is. And there's a lot of talk of self-driving cars right now. And if one of the risks is if they're all using the same kind of algorithm, it might look like 99.9% of the time they're all driving the same and driving just fine. But on that one morning where the fog is at the perfect level and the rays of sun are hitting the signs at the perfect angle, there could be this failure that ends up being systemic. Okay? So humans are going to make errors in driving or categorizing, but not all humans are going to make the same mistake at the same time.
Right.
Whereas if you allow AI algorithms to run all of the vehicles in your city, on that one foggy morning, all of them could potentially go haywire and lead to issues.
So
in the traffic.
In these examples, are the algorithms that are being used to make those decisions? I'm air quoting here.
Right.
Are those algorithms the stacked algorithms, or are they the base algorithm itself?
The algorithm that makes the decision is the second one, the one that's generated.
Okay.
And these are just normal, really good machine learning algorithms. There's nothing wrong with the main algorithm. It's just a way to say, hey, be careful of some of the inputs might not match perfectly. We see this also in things like chatbots or things like natural language processing, where we want computers to understand human speech. it looks really impressive on certain inputs. Like you can have this conversation about your vacation, but then you ask the computer something like, what is 2 plus 2? And then they'll act like, those are some interesting small words or something. Like it can't shift gears to now, oh, that's a math problem, I'll answer 4. So beware. Something to talk to your vendor about is sort of robustness or reliability on these things. Like, this is really impressive. You just showed me a robot that's doing somersaults or something. But what if it moves a half inch to the left? Can it still do the somersault? Like, there are going to be some really small changes that end up severely impacting the ability of the algorithm to still perform. And those are things that you as a CEO, CFO in charge of deploying these algorithms and purchasing them for your company should be aware of. The promise of AI is real and it can lead to human flourishing, but we have to be sure that it's not misused.
So a little follow-up on that. In your experience, the use cases for AI that maybe are a little bit further down the line from maybe some initial testing, how robust are the testing procedures for those implementation and use cases? Are they years and years and years of non-failure?
No, definitely not years.
What are the time frames here?
Very short, really, because we develop it, and so we make sure that it fits whatever tolerance the engineering application needs. If you have a robot that you want to, for example, there's AI in the Mars rover, right? We can send a robot to space now. That's pretty cool, and we can drive around and make some decisions. And that works well enough for NASA to decide to deploy it. But did they do years and years and years of testing on all those algorithms? Some of them do date back a far ways, and they're standard algorithms that we're pretty sure, like it can detect whether there's a rock there that's going to be used for scientific study. But other ones in a normal development cycle, we're just hoping that they work.
So if the rover runs across an old tire on Mars,
it might not classify that, or it might think that's a rock, and we'll be sending back images of alien tires instead of rocks. And where will we be in that case?
Thanks for watching. If you enjoyed this segment, check out the entire episode, and if there's a topic you'd like to see us cover, comment below.